Hello, Accelerated Math 6-7 students. Welcome to our 7th video. Turning to the table of contents for the 7th video, it is called Comparing Ratios Using Ratio Tables and Double Number Lines. We can find this lesson on page 22 of my comp book. So when you guys have that written, we're going to turn there. So here is page 22 of my comp book. And let's take a look at what we're doing today. So comparing ratios using ratio tables and double number lines. Today we are going to learn how to compare ratios and ratio tables and what double number lines are using double number lines. Okay. Our question for today is, how do ratio tables and double number lines show a comparison? So that's something that you need to be thinking about. And notice that the word show is in quotation marks. The reason for that is because you need to be able to see what the ratio is on both of those tools. So what does the ratio look like on a ratio table, and what does the ratio look like on a double number line? Okay. So just a quick review for us. Ratio tables contain equivalent ratios that sometimes must be compared. And so in this first example, what we're working on is we're going to compare Amy's table to Rachel's table. And we will see that the independent variable is drops of lemon juice. The dependent variable is cups of water. Okay. On Rachel's table, same thing. The independent variable is drops of lemon juice, and the dependent variable is cups of water. So if we look at Amy's table, we notice that for every 8 drops of lemon juice, it takes 2 cups of water. 16 drops of lemon juice, 4 cups of water. 24 drops of lemon juice, 6 cups of water. And 32 drops of lemon juice, 8 cups of water. So that's what we're noticing about Amy's table. Now let's look at Rachel's table. Rachel's table says drops of lemon juice, 2 cups of water. So for every 15 drops of lemon juice, it takes 3 cups of water. For every 30 drops of lemon juice, it takes 6 cups of water. For every 45 drops of lemon juice, it takes 9 cups of water. And for every 60 drops of lemon juice, it takes 12 cups of water. So what we're trying to figure out is, do either of these tables have anything in common? Okay, because remember we say sometimes the tables must be compared in order to figure out the information. So what do you think that these two tables have in common? Well, I'm noticing 8, 16, 24, 32, 15, 30, 45, 60. I'm not really seeing much that they have in common other than the fact that they both are talking about lemon juice and they both are talking about cups of water. So they must be like trying to build some kind of lemonade or something like that. So right off the bat, that's the only thing that I would say they have in common. The next question is, could you determine how many drops per 1 cup of water? Okay. Could you determine how many drops per 1 cup of water? And so basically we're saying, okay, we have 2, 4, 6, 8. If we were to put one more row on each of their tables, could we figure out what it would take for 1? And so that's what I would like you to do. So looking at this very quickly, let me move this up so we can work on it together. Let's try Amy's first, okay? So I'm not going to write out the whole table again because we'll just use the parts that we need. So we know lemon juice drops, so I'll put DLJ for lemon juice drops, and then water, okay? So we know that for every 8 cups of water, or 8 drops of juice, it takes 2 cups of water. So now I want to figure out how much it takes for 1 cup of water. So the question is, how did I get from 2 to 1? That's correct. I divided this by 2. What you do to one side, you have to do to the other. So I need to divide this side by 2. And so 8 divided by 2 is 4. So now I know for Amy, for every 4 drops of lemon juice, she needs 1 cup of water. Okay, that's what I know for Amy. So that's Amy's. All right, so now let's try Rachel's. So again, I'm not going to build the whole table. I'll just build what I have on the first one. So again, we're saying drops of lemon juice for cups of water. H2O is water. And on this one, I know that it takes 15 drops for 3 cups. So now my question is, can I get to 1 cup? So to go from 3 to 1, how do I get that? That is correct. You're going to divide by 3. What you do to one side, you have to do to the other. 15 divided by 3 is 5. So now I know for Rachel, for every 5 drops of lemon juice, she needs 1 cup of water. So what did we learn by doing that? Because basically what you guys just did is you compared the tables. What did we learn? I would say what we learned is that Rachel's recipe calls for more lemon drops for her lemonade, if that's what they're making, okay? Because she has to have 5 for everyone, whereas Amy only has to have 4 for everyone, okay? So we learned that Rachel's lemon juice or lemonade, if that's what she's making, probably is a little more potent and requires more lemon juice than Amy's, okay? So that's what we are talking about when we're saying sometimes ratio tables contain equivalent ratios, sometimes that must be compared, and so that's what we have, is we had to compare what we saw, okay? Basically what I would like to do next is I want to keep going with this, and then we answered that question already. It says who uses more lemon juice in their lemonade, and we found out that Rachel uses more lemon juice in her lemonade, so you can write in Rachel right there for me. Okay, the next thing I want you to try is we're going to check out some soda. So a liter bottle of cola, you know those liter bottles, they come in, they're tall and they're plastic, okay, liter bottles. A liter bottle of cola contains approximately 34 fluid ounces, okay? How many grams of sugar would be in a liter bottle of cola? So basically we're trying to figure out when you drink a whole liter of cola, whatever is your favorite cola, how many grams of sugar are you getting? Okay, and so what we need to do is we need to use some of our tools that we've been learning about to figure this out. Just information for you to use, there are 20 grams of sugar in 6 ounces of cola. Wow, that's a lot. 20 grams of sugar in 6 ounces of cola. All right, so the first thing that I want you to do is I want you to make a ratio table. Okay, now this is a sideways ratio table. I just took the tall ratio table and I turned it over on its side. And so we're using it the exact same way. I have cola in ounces. For every 6 ounces of cola, there are 20 grams of sugar. Okay, and so this, you can have a ratio table standing vertically, which is what you guys have seen all along, or it can be horizontal and you just use it the exact same way. Okay, so if we were going to fill in this ratio table, I'm going to draw one right here. You guys fill it in on your paper. I'm going to draw mine right here. So I'm going to say cola, sugar, and the ratio is for every 6 ounces of cola, there are 20 grams of sugar. So the first thing that I want to do is I want to figure out how to break this into sections so that we can figure out 34, because that's what it asked us right here. How many grams of sugar are in 34 fluid ounces? So I'm just going to build this table like we know how. How do I get from 6 to 12? How did I do that? You're right, I multiplied it by 2. So what you do to one side, you have to do the other. So 2 times 20 is 40. Holy moly, this is a lot of sugar. Okay, and then 6 times 3 is 18. 20 times 3 is 60. Oh, good grief, this is going to make me very nervous. 6 times 4 is 24 ounces. 20 times 4 is 80 grams. Yikes. 6 times 5 is 30 ounces. 20 times 5 is 100 grams of sugar. Holy moly. 6 times 6 is 36 ounces. 20 times 6 is 120. You guys are consuming a lot of grams of sugar. And then 6 times 7 is 42. 20 times 7 is 140. Now, the question that we need to figure out, though, is does the ratio table tell us the answer? So let's look at it. we need to know how many 34 fluid ounces is. Do you see 34 fluid ounces anywhere on here? And the answer is no, we don't. We go from 6 to 12 to 18 to 24 to 30, 36, 42, but look, 34 would be somewhere in here, okay? And if we're trying to figure out how many grams of sugar are in a 34 fluid ounce bottle, the ratio table isn't really helping us that much. So there's another tool that I want to teach you how to use, and it's called a double number line. Okay, and it is exactly what the title calls it. You take two number lines, all right, and you put on information so that you can learn from it. So I need everybody to make the double number line. Basically what you're doing is you're doing a comparison between two different things, cola and sugar, and you make a number line for each of them. So here's the number line for cola, here's the number line for sugar, and then what we do is we connect them by making the amounts of each type connected. So when we have 0 ounces of cola, we've used 0 ounces of sugar. Does everybody see that? Okay. Then we also know that when there's 6 ounces of cola, there are 20 grams of sugar. Does everybody see that? And then you can just use your ratio table again. So if we multiplied that by 2, then we would put a 12 right here. I'm going to go ahead and write this in so that you guys can do it with me. So we would go 2 times 6 is 12, 2 times 20 is 40, 3 times 6 is 18, 3 times 20 is 60, 4 times 6 is 24, 4 times 20 is 80, 5 times 6 is 30, 5 times 20 is 100, and then 6 times 6 is 36, and then 6 times 20 is 120. And you're sitting there going, okay, Mrs. Nelson, I don't get it. I don't know why you did that. Well, the reason why we're doing this is because when you used the ratio table, you didn't really have any wiggle room to figure anything out. The beautiful thing about a double number line, however, is that you can now know that you have these different sections. You can now very easily find an amount that would be easy for us to find 34. So if we're looking for this and we're trying to get to 34, what number do you think would help us to easily get to 34? We know it's somewhere around in here, but how are we going to know how much of each one we have to use? So the thing that I would do to make it very simple for you is, could we find for 1? We know for 6 ounces, 12 ounces, 18 ounces, 24 ounces, 30 ounces, 36 ounces, but could we find for 1 ounce? Because if we find for 1 ounce, then all we have to do is multiply that by 34, and we will figure out what 34 is. Boys and girls, do you see how easy that is? I hope so. So basically, you're going to put one more line right here, and we're going to call this 1. So now the question is, you have to do some math here. How did you get from 6 to 1? Everybody? That is correct. You divided by 6. What you do to one side, you have to do to the other. So again, if we have our scratch paper, I'm going to do it on here because it's easier for me to do it here. So here's 0. Here's 1. We just did 1. Here's 6. And this one was 20. So in order to get from 6 to 1, we did 6 divided by 6. What you do to one side, you have to do to the other. So again, I do 20 divided by 6. 6 can go into 20 3 times with 2 leftovers, which gives me 3 2/6 or 3 1/3. Does everybody see that? Okay, so we now know for every ounce of cola, it is 3 1/3 grams of sugar. Okay, so that little guy where we put the 1, you would write 3 1/3. So we're going to write 3 1/3 right here. And now what we want to do is we want to find out what 34 would be, which is very easy now that we know what 1 is. So I'm going to say 34 is about right here on my double number line. Write in 34. And then I ask myself, how did I get from 1 to 34? Well, that's not too hard. How do you get from 1 to 34, kiddos? Correct. You have to multiply by 34. So I'm going to take 1 and multiply it by 34, and I'm going to take 3 1/3, and I'm going to multiply it by 34. So 1 times 34 is 34. That was pretty easy. 3 1/3 is the same thing as, we've got to put this back into a fraction greater than 1. So 3 times 3 is 9 plus 1 is 10. So I have 10 thirds times 34. Not too hard, right? 10 times 34 is 340. You guys learned that earlier on in your mathematical careers, I hope. 3 times 1 is 3. And now I just have to finish it up so that everybody understands the number of grams. And kiddos, on this one, I do want you to find out exactly what that represents. So we're going to take 340, we're going to divide it by 3. The reason why we're finding it exactly is because over here on our double number line, we want to understand what the grams are. So 3 goes into 3 one time, 3 goes into 4 one time, and 3 goes into 10 3 times, with 1 left over. So now we know that 34 ounces of cola gives you 113 1/3 grams of sugar. Oh my goodness. No wonder you get rotten teeth after you drink all that soda. No wonder you run around like a crazy person. Hyper, hyper, hyper. Look at all that sugar that you just consumed by drinking a 34-ounce liter bottle of cola. Crazy. Okay, so let's see if we answered the question. How many grams of sugar are in a liter bottle of cola? The answer is 113 1/3 grams of sugar. So now that's basically our entire lesson, believe it or not. But I have a question for you. Which tool did you prefer? Okay, I'm going to go with double number line because I could actually find the answer. The ratio table, when we filled it in, we didn't ever find the actual answer. We found in the middle, and we would have had to make a guess, right? But we weren't actually able to find it. And so now you know that ratio tables are very helpful sometimes, but other times we need something more specific, right? So that's why I'm teaching you today how to use the double number line, and it's fabulous. Oh, the other thing that I want you to be really careful about, always label them. So this should have said cola, this should have said sugar, okay? So whatever you're working with on the double number line, you have to put your labels on, because if your labels are not there, you're going to get confused. All right, so let's revisit our question of the lesson. Our question of the lesson was, how do ratio tables and double number lines show a comparison? So my answer on that is, does a ratio table really show the comparison that well? Not as much as the double number line for sure shows us the comparison very clearly, and we now know how to use tools to use it. Okay? All right. I don't think I left you anything to do by yourself, so we will just come up with some questions for you to work on in the morning when you get here. All right. Have a great time. Bye.